The universe is enormous. Not just big, not just vast, but so overwhelmingly gigantic that our minds aren't built to grasp it. You've heard the numbers: light years, millions of stars, billions of galaxies. But those words have lost their punch. They've become just numbers. So today, we're going to do something different. We're going to rebuild your sense of cosmic scale, from the solar system you think you understand to the very edge of everything we can possibly observe. And along the way, you'll discover something unsettling. The universe we can see is only a tiny fraction of the universe that actually exists. Let's begin with a single light year, the distance light travels in 1 year. That's about 9 trillion kilometers. It's an impossible number. If you counted 1 kilometer per second, non-stop, it would take you nearly 300,000 years just to reach 1 trillion. Now multiply that by 9. That's 1 light year. And yet, when we talk about the cosmos, we throw around light years like they're nothing. But they're not nothing. They are the only unit large enough to keep cosmic numbers from becoming completely absurd. We use them because nothing else works. So let's start nearby. The solar system, our entire home, is only about 8 light hours wide. A photon of light could cross it in a single day. Beyond that lies the Milky Way, a sprawling collection of around 200 billion stars, each one with its own planets, its own stories, its own history. Our galaxy is about 100,000 light years across. To put that in perspective, if the solar system were the size of a coin, the Milky Way would be the size of North America. And then there's Andromeda, our nearest major galactic neighbor, 2.5 million light years away. You could fit 25 Milky Way galaxies end to end in the space between us and Andromeda. That's just our local area. Now, imagine everything beyond it. The observable universe isn't the universe. It's just the part we can, theoretically, detect, because light from those regions has had enough time to reach us since the beginning of time. And that limit comes from one number: the age of the universe, 13.8 billion years. Now, you might think the farthest thing we can see should be about 13.8 billion light years away. But that's wrong. Very wrong. The actual radius of the observable universe is 46 billion light years. And the whole diameter? About 90 billion light years across. Why? How is that possible? Because while that ancient light traveled toward us, space itself expanded beneath it. The universe stretched, carrying distant galaxies far, far away from where they originally were when they emitted that light. So, the light we observe today began its journey 13.8 billion years ago, but its source is now 46 billion light years from us. This isn't intuitive. It isn't meant to be. To understand this expansion, imagine raisins baked into a loaf of rising bread. The raisins don't move through the dough. The dough itself expands, carrying them farther apart. Galaxies behave the same way. They aren't flying apart like shrapnel from an explosion. The space between them is stretching. And here's the twist. Space can expand faster than the speed of light. And it does. This doesn't break the laws of physics, because nothing is moving through space faster than light. It's the fabric of space itself that's changing. This stretching is why distant galaxies appear to be racing away from us. And we measure this effect using something called cosmological redshift. Light has a wavelength. Shorter wavelengths are bluer, longer ones are redder. When space expands, it literally stretches these light waves, pushing blue light deeper and deeper into the red end of the spectrum. This stretching is measurable, and it corresponds directly to how much the universe has expanded while that light was in transit. The farther away the galaxy, the longer its light has traveled, the more space has had time to expand underneath it, and so the stronger the redshift. By measuring millions of galaxies and plotting their redshifts against their distances, astronomers can reconstruct the entire expansion history of the universe. Every slowdown, every acceleration, every cosmic phase change. This is how we know that the universe was once slowing down, but is now accelerating again, driven by a mysterious force called dark energy. But that's a story for another episode. Once we know the expansion history, we can run the universe backward, like a cosmic home video in reverse. Galaxies drift closer together, distances shrink, and eventually, everything converges into a single, unimaginably hot and dense point: the beginning. At full rewind, we reach the Big Bang. The time it takes to get there is the universe's age, 13.8 billion years. Now, let's play the tape forward again. Imagine every galaxy sending out a beam of light just moments after the Big Bang. Those beams travel outward, while space stretches violently beneath them for billions of years. One of those ancient beams of light arrives at Earth today, but the galaxy that emitted it is now 46 billion light-years away. That's the boundary of our observable universe. Everything we just described refers only to the part of the universe we can see. Beyond that boundary lie regions whose light hasn't reached us yet and may never reach us. They aren't gone. They aren't imaginary. They are simply too far away for their light to overcome the constant expansion of space. So the full universe could be 100 times larger than the observable region, or it could be infinite, or it could be something stranger than anything we've ever imagined. We simply don't know. And that's the ultimate mystery. When you look into the night sky, you're not just seeing stars. You're seeing time. Every object is a time capsule, a message from a younger universe. The farther we look, the younger the cosmos becomes. Until eventually, we see not galaxies, not stars, but the faint, glowing afterglow of the universe's earliest light. We are staring into the baby picture of everything. And everything we see, all 90 billion light-years of it, is just the part of the room where the lights are on. Beyond that, darkness, or more light waiting to arrive, or an infinite cosmic ocean stretching forever. The truth is, we live inside a bubble of visibility, floating in a much, much larger reality. If this journey reshaped how you see the universe, you're not alone. Most people know the universe is big, but few understand how we know it, or how much bigger it might truly be. Stick around, because in the next episode, we'll explore what could lie beyond the observable edge and whether our cosmic bubble is just one of countless others. This is Curio Clips, where we explore the biggest ideas in the biggest universe we can imagine. See you next time.